This is part 2 of our video on solving logarithmic equations. So we're going to take a look at another equation. This one's a little bit longer than the last one. So it says 2 log to the power of 3x plus 3 log to the power of 2x minus 17 equals 10 plus 18 log x. So factoring is a good idea when you have multiple terms that have variables, right? So I have multiple terms here that have variables in them. I also, when I want to factor, am looking to see that they are maybe the same base, the same argument, but they have different exponents. Those are usually the things that I'm looking for when I decide that I want to factor with logs. Now, to be honest, I think the easiest way for us to tackle this is actually to do some variable replacement and maybe take out the log x and put in, say, an a. So I am going to let a equal log of x. I'm actually going to put a bracket around the x just out of habit, which means this is going to become 2a to the power of 3 plus 3 times a to the power of 2 minus 17 equals 10 plus 18 times log x, which is a. Okay, so I did say to begin with, our goal really is to try to make this polynomial. So I've done that, right? It's now a polynomial, so we are going to try to solve. We have multiple variables, right? We've got lots of terms with variables. There's at least 3 of them here. So I would like to solve by either factoring or quadratic formula, meaning it needs to equal 0 on one of the sides. So I always look for the highest exponent term, which is the a cubed, and I would like its coefficient to be positive, which it is. So I'm going to move the 10 and the 18a over to this side. So if I move the 10 and 18a over to this side, I get 2a cubed, right? I have 3a squared. We are going to subtract 18a. It doesn't have a like term partner on the other side, so it's just subtract 18a. And then I am going to subtract 10 from both sides. It is like terms with the 17, so negative 17 minus 10 is negative 27. And then all that's left on the other side is a 0. Okay, so from here, I want to see if we can factor, right? It has too many terms for the quadratic formula. Quadratic formula only works with 3 terms. This has 4. So I would see if I can factor. So I don't have my flowchart with me, but first thing I would look for is, does it have a common factor? Unfortunately, 2 and 3, the only thing they have in common is 1, so I'm going to say no. And then I'm going to see, can I group? It is always worth trying, because the alternative is factor theorem, which is a lot of work. Okay, 2a cubed plus 3a squared. They do both divide by a and squared, right? I would have to multiply a squared by 2a to get 2a cubed. I would have to multiply a squared by 3 to get 3a squared. All right, I always take the sign that's in between. 18 and 27 both divide by 3, but we can actually go a little bigger. They both divide by 9. So what would I multiply 9 by to get negative 18a? 2a. What would I multiply negative 9 by to get negative 27? Positive 3. So factoring by grouping obviously is going to work because these 2 brackets came out to be the same. So this is going to be 2a plus 3 and then a squared minus 9. And that equals 0. Okay, am I done factoring? Well, the first bracket does not have an exponent and there's no common factor, so it's done. But this one here is still a difference of squares. So I can say this is 2a plus 3, and then this would be a plus 3, a minus 3. I would square root each term, 1 plus 1 minus, and that still equals 0. So from here, we're going to take each bracket, set it equal to 0. So 2a plus 3 equals 0. A plus 3 equals 0. And a minus 3 equals 0. Okay, If we take 2a plus 3 and we rearrange, I would subtract 3, so 2a equals negative 3, and then I would divide by 2 to get that a is negative 3 over 2. If I do a plus 3 equals 0, I would take that 3 to the other side and get negative 3. And then a minus 3 equals 0. I'm going to add 3 to both sides to get a equals positive 3. Now, these are not my final answers because my original question did not have a's in them. They had logs in them. So you do have to put the log back in, right? So that is going to give me log x. I'm going to use the bracket. I know there wasn't one in the original question, but it's a good idea to have the bracket. Is negative 3 over 2. This one here, log x equals negative 3, and log x equals positive 3. Now those logs don't appear to have a base, but they do all have a secret base of 10. And at this point, we are going to have to do some rearranging. We have one variable to solve for, right? So doing a little rearranging would be a good idea. The opposite of a log base 10 is a power with a base of 10. So this one, x is going to equal 10 to the power of negative 3 over 2. This one, it's going to be x equals 10 to the power of negative 3. And this one is going to be x equals 10 to the power of 3. Okay, 10 to the power of 3 is 1,000. So one of my options is 1,000. 10 to the power of negative 3, a negative exponent makes a fraction. So this would be 1 over 10 to the power of 3. Or it does say that you are allowed to use a decimal. So we could just calculate 10 to the power of negative 3. I would rather leave it as a fraction. So I'm going to say this is 1 over 10 to the power of 3. 10 to the power of 3 is 1,000. Normally I would do that in 2 steps, but I don't have enough space. And then this one, I'm out of space. So I'm going to bring it over to the side here. And I'm going to do x equals 10 to the negative 3 over 2. Now, a negative exponent makes a fraction, and a fractional exponent makes a root. So I'm going to start with just the negative exponent part. This is going to be 1 over 10 to the power of 3 over 2. So this is going to be 1 over the square root of 10 to the power of 3. Now, it did say to use a decimal, so we are going to calculate that. I'm going to try to use my computer to do it since I don't have my calculator with me. Okay, so we're doing 1 divided by, and then I'm going to use the second function of my exponent button. And I got 0.0316. So it said 3 decimal places, so that's approximately 0.032. All right. So my 3 solutions are x equals 1 over 1,000, x equals 1,000, and x equals approximately 0.032. Now, I did mention that you want to check and make sure that none of these make the original argument in the question a 0 or a negative. So if I look, my original argument was just x, right? So if x equals 1 over 1,000, is that 0? No. Is that a negative? No. So same thing, it's just an x. So what if x equals 1,000? Is that 0? No. Is that negative? No. And then if I put in 0.032, if x is 0.032, also not a 0 and not a negative. So all 3 answers are fine. So I'm going to say x equals 1 over 1,000, or that is 0.001, 1,000, and approximately 0.032. Can you see that? There we go. Okay, so I will see you in the next video to talk about the next method.